Hi, welcome to Module 3. This is modeling data. So in the first module, we learned about what ClickHouse is, and in the second module, we took a nice deep dive into the architecture. And now we're ready to start creating tables, creating databases. We're going to talk about the data types in ClickHouse, including some very important ones like low cardinality, and then we'll see how arrays work and what nullable does. And then we'll talk about the primary key again, because it's such an important aspect of ClickHouse. I want to go into more detail about how to define those and how those work. And then a discussion on partitions, which I've quietly avoided until now, and you'll see why when I talk about partitions. As you can see, Module 3 is a part of this 12-module learning path that we have called ClickHouse Developer. All right, let's get started. All right, let's take a look at how to model data in ClickHouse, starting with the sort of beginning point of any sort of task you would probably do would be to create a database and a table. Creating a database in ClickHouse is super typical of probably anything you've ever seen before. You use the create database command. A database in ClickHouse is really a namespace. It's a way to group your tables in some convenient or clever way, but it's really nothing more than that. So, if you had one database with 100 tables in it, if you had 100 databases, each with one table in it, that's still 100 tables, and the resources would be effectively the same. It's maybe the folder structures would be different behind the scenes, but that's really about it. So you create a database just like you would with any other SQL database. You do get the 3 sort of free databases by default, and you can see these if you're over here in the SQL console. And there's this little drop down here. You can see default and system. There's the 2 information schema ones. Those are part of the ANSI SQL standard, and they really have sort of, nothing interesting in them that's outside of what's already in the system database. And so I don't even click on them. Like I just, if I need something interesting, I look in the system database. It has 103 tables. That number changes based on all your settings and whatever you have. But notice if I go inside here, for example, there's a table called databases, and it shows me all my databases. There's a table called merges that shows all the merges happening in the background right now. There's a table called parts. Remember we talked about parts in the previous lesson on the architecture of ClickHouse and how the part folders contain, well, that's where your rows live. And so you can see all the names of your parts here, which are the names of your folders. If I can make that wider, you'll see that this first row is probably that UK table. If I go over here to the right, where is the table name? Yep, it's UK price paid. So right now, those 28 million rows of UK property data that we've been sort of using in the previous lessons is just sitting in one part. How do I know that? Well, there's a clever table in the system database that shows that to me. All right, so I'll close those up. And let's go back to the slides here. So you've created a database, and now it's time to create a table. Lots of table engines. Every table in ClickHouse has to have an engine. The engine is where the data is stored. If you're, pulling data from Kafka or Hadoop or another database or something like that, there's engines for that. When the time comes for you to put that data into ClickHouse, that's when you're going to put it into a merge tree table. Well, we do have some special types of table engines as well, and these are in the docs. This is worth going over and taking a look under the SQL reference, and you can see the merge tree table engines that we talked about in detail in the previous lesson, the integration ones, which connect to outside resources like other databases, message queues, cloud storage, all those types of things. And then the rest of them, all table engines are special. These just happen to be the leftover ones, and we just call them special in the docs. But things that some of these we'll talk about in detail later on, like we'll talk about dictionary when we talk about joins. Trying to think, we do talk about the join table engine as well later on, the file table engine for reading from a file, and so on. So you can see there's other ones. And like we said, when you're ready to put the data into ClickHouse, that's going to be the merge tree table. I have a simple example here, just a table called my table and a database called my database, and it's got 4 columns. Of course, if you have a merge tree table engine, you have to have a primary key. That's a requirement. The primary key is the sort order, as we well know now. Notice the data types. If I go back a slide, I did like uint32 and string and date time and so on. These are ClickHouse data types. If you go to the system table, I'll just read these. I'll just show the whole results here. It's called data type families. This is a table in the system database, and It just contains all the possible data types that you can use when you create a table in ClickHouse. So that's what I think is really interesting about this. Now, if you scroll down here, you see that these first ones don't have any aliases. These are the built-in ClickHouse data types. And if I scroll down to row 59, which is actually the 60th row because it started at 0, there are 59 built-in ClickHouse data types, and all the other 70 some that are in this table all have an alias to one of the built-in ClickHouse data types. So keep that in mind. And if I go over here to the docs, we have a nice little page in the documentation on the SQL reference page that lists them all. You can see we have a page with all of them listed here, the 59 that we have. And they're nicely broken down into categories. These are the numeric types that look a lot like C++ data types, but that's shouldn't be a surprise. That's what ClickHouse is written in. There's a couple of floating data types. They differ in size. If you are using floating point numbers, we highly recommend you use decimal instead. It stores these floating point numbers as 2 integers, so you don't lose any precision. It can actually be more efficient. So keep that in mind. You'll notice I use decimal quite a bit. There's Boolean, there's string. This is a big one. String has got all kinds of things that are aliases to it. There's 4 types of dates. There's date and date 32. Those represent days. And then there's date time, which represents seconds. And date time 64, which is whatever precision you want. You can put a number from 0 to 9 in there. So that's from seconds to nanoseconds. We'll talk about enumerations, low cardinality, arrays. We'll talk about some of these like nullable. Actually, right now, that's the next thing I want to talk about in the slides. So this is that slide where if you wanted to, you could look and see what all the aliases to strings are. If you're wondering where varchar is, or clob, or blob, or char, or text, we just alias all of those to string. String is of unlimited length in ClickHouse. So there's a lot of data types. I don't really have time to go through all of them, so I kind of just cherry picked a few of them, starting with arrays. And I think they're interesting. In fact, what I think I'll do is I'll just kind of work through an example here. Let me start at the beginning. Let's create a database. Let's say I wanted to create a database. I'll just call it rich. And then I want to create a table in that database. So then you'd use the little syntax there. I don't know. I'll just call it friends will be the name of the table. So rich.friends would be the syntax there. And let's say that my friends have a name, so I'll use string. Again, I could put like varchar or something there, but that's simply an alias to a string. I can put the birthday on there. That's a day, so I'll use date for that. Let's put their age. I don't know. I'll just do a uint 8. That should be big enough for everyone I know. And then that's probably good enough for now. Now I'm creating a table, so I'll have to give it an engine name. So we'll call it merge tree, which means I have to have a primary key or an order by clause, one or the other. I'll just order by name. And let's create the table. And then over here on the left, you'll see, at least in the SQL query, did I not run that command? I think I typed the command but didn't run it. Now let me run this command. Yeah, that worked. And then if I go over here, you'll see rich. Now is the drop down for my database name. And then you'll see my table friends, which should be empty. Yeah, I don't have anything in it yet. All right, well, let's put some rows in there. I was going to put an array in there. I wanted you to see what an array looks like. Here, I'll just add the column. This is easy. This will be a nice little lesson in altering the table. We'll alter table rich.friends, and we'll add a column. Let me call it meetings. Let's say I just want to keep track of every time I met one of my friends, and that'll actually have a moment time, a certain time of day, not just a day, but a time of day. So I'll use date time for that. Look how nice this is in ClickHouse. You can just put array around the data type, and now that column will be an array. So if I want to show the create table command for rich.friends, you'll see that I have meetings as an array of date time. That's perfect. I like that it shows primary key as name and order by his name also, because like I've said many times already when we've talked about that before, that the primary key and the sort order are the same. Let's play around with those arrays. I'm going to insert into rich.friends, and I'll just put some things in here. This is fun to do. Let's suppose I have a friend named Thomas, and what was like the next thing? Oh, like a birthday. Now that was a day, so I'll just pick like, I don't know, I'll just pick like 1970. We'll do December 2nd. And then if I want to pass in an array, oh, I think there was an age. Well, if someone was born in 1970, they'd be like 54. You can do square brackets with arrays. And then I can just put like some date and times in here. So if I met that person on, you know, January 5th at 9 a.m., you can do that. Or, you know, you can put a comma, and then what's nice about these times is you can just put in a number and it just knows that it's it's like epoch time or whatever. So that's pretty cool too. Let me put in, let's put a name in there. Let's do Claire. Let's say 1998. This was the birthday column. Again, the dates are nice. You just type it in there and ClickHouse figures out it's a date. That person would be about 25. Let me show you something else that's cool about dates. There's a function called now that just returns the current timestamp up to the current, you know, its current second. And then you can do something super easy in ClickHouse. You can say like, you can do math on dates. So for example, if I want to go back 1 week, I can literally just type that. I can just say now minus interval 1 week. There you go. Let's see if that works. That should work because I put in 4 columns. Oh, thank goodness that worked. Let me select star from rich.friends and see what we got. And you can see that those are arrays. By the way, if you do, they're one based. So if I select the first column from rich.friends of that, of the meetings column, you get back the first value. 0 doesn't make sense. I don't think 0 would. Yeah. What even tells you array indices are one base. So putting 0 there doesn't make sense. So, all right. So that's how arrays work. Super cool how, you know, they're just very simple to work with. The example I had here was an array of strings. I actually use the array function. That works as well. So instead of using square brackets, you can just call the array function, pass in as many arguments as you want. That's another way to create arrays as well. The nullable type is interesting in ClickHouse. You can make a column nullable. And what that means is if the column is missing in some capacity, it will actually be the value null. As opposed to, let's say, like the size column in this example. The size column is not nullable. So if a value is missing for size, it'll be 0 because it'll get the default value of its data type, which for uint64 and for any number is going to be 0. And so, yeah, let's take a look at it. I mean, that was fun. Let's alter our table again. And let's add a column. I'll just add the same 2 columns that were in the example there. So size was a uint 64. It was not nullable. And metric was nullable. So I'll do metric, and that'll be a nullable uint 64. Let's see what that does. Let's see if I type that right. I did. Let me insert into rich.friends. And I'll just pass in the 2 values. I'll just pass in size and metric. And I'll just pass in the values. I think the slide had 100 and then some big number. And then it had like null and then some big number. And then so the size will be null in that example. And in this example, you know, the size can be like 200 and then I'll pass in null. So that's the metric. So I'm passing in null in the second row for the size and then null for the third row that I added. Let me select star from rich.friends and see what happens. You can see that the size is just 0. Anytime the size is missing, it's just 0. Oh, you don't really see the null in the SQL console. Let me show you something. You see it a lot more clearly. I had something similar. I'll go over to the terminal screen and let me show tables. Let me see if I'm in the right spot here. Oh, show tables in rich. There we go. Select star from rich.friends. You can actually see the null right there as opposed to the 0 and the null up here where it's missing in those rows where it wasn't there before. That's different. There's more to null than just being 0. If I want the average metric, it'll just be these first 2 values and then the null will be skipped. It won't affect the average or something like that. If it's important for the business logic, then use nullable. If it's not important for your business logic and 0 is okay, then don't use nullable. Nullable does something interesting behind the scenes. It adds a hidden column. So for every nullable column in your table, like metric is one example, you'd have a hidden column for metric that's just a bunch of ones and zeros. And it'd be 1 every time the value should be null and be 0 when it's not null. And that costs you something. Now, it's not super expensive, but it costs you something. And if you had dozens of rows and you made them all nullable and you really didn't care, you'd have dozens of hidden columns and your table would be that much sort of heavier. You know what I mean? There's no reason for that. So we don't recommend you do that. We only recommend you use nullable when it's business logic and it's important to you. Otherwise, we don't recommend you use it. But I wanted you to see the difference in that. So that's the nullable data type. There's a data type in ClickHouse called enum for enumerations. Here I have a table with a device type that is either server, container, or router. And I set them equal to 1, 2, or 3. That's kind of cool. Yeah, they're strings, but they're stored as integers behind the scenes. It's much more efficient. So, and you treat them like strings. When you insert some rows like I did here, a router and container, you actually pass in strings. There's a downside if you try to pass in something like pod. Well, that, if I go back a slide, that wasn't one of the 3 values. So that's actually going to throw an exception. So that is kind of the downside to enumerations. But if you were to filter by container or something, you treat it as a string, but it is stored as a number behind the scenes. Very efficient. If you have billions of rows, this is a massive efficiency gain. Very important to use enumerations when you can. Take it one step further. So there's a data type called low cardinality. It's kind of like an enumeration, but it's actually a little more powerful. You don't have to know the values ahead of time. You don't have to assign strings to 1, 2, 3, 4, and so on. ClickHouse will do all of that for you behind the scenes. You can just take a column. Let's say you have a string column and it only has, we recommend maybe like 10,000 unique values. That might sound like a huge number of cardinality, but in ClickHouse, it's not a huge number at all. Think about how many use cases you could have for that. You probably have a lot of columns that have a cardinality of 10,000 or less. Wrap that column type in a low cardinality. It'll be stored as numbers behind the scenes. You'll see a noticeable difference in storage space and a noticeable difference in query performance, because ClickHouse can treat those values as integers. We highly, highly recommend you use low cardinality. You can use it for things like enums as well. It's super convenient. And so you'll see that we use that in quite a few of the examples. Like here, I made the type column a low cardinality string. Now I can pass in any string I want. Now I only passed in like 3 different values. Yeah, you treat it as a string. Behind the scenes, ClickHouse stores it in this optimal way. So big fan of low cardinality. We highly recommend you use it. All right, change of subjects. Let's go back and look at primary keys. We talked about how the primary key is the sort order. Every merge tree table has to have a primary key. You can define the primary key. This is all just syntax here. You can define it inside the column list or outside the column list. It's the same table. ClickHouse doesn't care. We just support it because other databases, support it. So we allow you to put the primary key anywhere. You can put order by instead of primary key. That's perfectly fine as well. These 3 tables, I'm going to go back a slide and back another slide. These 3 tables are the exact same tables. Nothing different, just a little syntax different, but they will be sorted by user ID then timestamp. If you do want the primary key to be different than the order by, I don't know why I put the primary key in the column list. I didn't have to do that, but I specified the primary key to be user ID and timestamp. And then for whatever reason, I wanted the sort order to also put message at the end. You know, maybe I'm doing a join or something and I need that data sorted by message, or maybe I know that message has a lower cardinality or something and it might be a great, compression. I might get better compression out of it or something. There's lots of reasons to sort by a column, but not put it in the primary key, because putting a big string in the primary key can be expensive. It's got to fit in memory. Now, this doesn't make sense. In this example, the primary key is user ID timestamp message. And I thought, let's sort by user ID and timestamp. Well, that doesn't make sense. If the primary key is those 3 columns, at a minimum, ClickHouse has to sort the data by those 3 columns. So your order by here, it doesn't make sense. The primary key has to be a prefix of the sorting key. All right, good to know. What's a good candidate for the primary key? I'd mentioned this in the previous module. The primary key is the most important decision you'll make in a merge tree table, because it's how your queries, when they filter on something, can skip granules. And so the best candidate for a primary key is that column that you filter on the most. If that's not 1 column, if that's 3 or 4 columns, then put them all in the primary key and put the lowest cardinality one first. So order them in ascending order of cardinality. That way you'll skip the most granules. How long should a primary key be? Look, you're only going to skip 8,192 rows at a time. Once you get past the first 3 or 4 columns, it rarely makes sense to add another column to the primary key. You're just adding overhead without skipping more granules. Only add a column if you know it's going to help you skip a bunch of granules. That's it. I mean, there is really no other reason to do that. So keep that in mind. We don't just put all the columns in the primary key. This thing has to be built and maintained in memory. Every time you do a merge, it has to be rebuilt. So, there's a cost to it. It's a nice simple example. It says, what might be an improvement to this primary key? I have user ID on here. Message is a string. It's not low cardinality, or I would have put low cardinality there. So it's probably pretty arbitrary. That's probably a bad idea for a primary key. Metric doesn't make a lot of sense in a primary key. It's just probably going to be a random number. Timestamp, sure. Why not add timestamp to the end of the primary key? I'm sure there's times where you're going to filter or group by the timestamp. That's something that involves the timestamp. So that's a great idea. In the same conversation, what's not great about this primary key? Well, again, message, that's a bad idea. A random string in memory is probably way too expensive to store. Not to mention if it's, why would I filter on message if it's a fairly arbitrary string? So I would have no gain from that. And then I added the 2 year, month. This is going to be like 2024, 02 for February of 2024. Well, that's pretty vague. I could have billions and billions of rows within that month. It's not going to help me very much to add that to the primary key. So I've said this already. The primary indexes have to fit in memory. If they don't, you're in trouble. ClickHouse won't even start, or it'll crash. If you wish you had more than one primary index, well, hang on. I'm going to show you as we progress through the training some other options. Now, you could just create 2 tables and sort them differently, and that is a perfectly valid use case. In fact, a materialized view, which is bullet number 3 here, is exactly that. It's a separate table with a separate schema and a separate name, and you store the data twice sorted differently. Hey, sometimes you just have to do that. There is something you can do called projections. Projection, it's a hidden table. We'll talk about that in lesson 12. Same with skipping index. That's lesson 12 as well. That's when we optimize ClickHouse. So hang in there. We'll talk about that in future modules later on in this learning path. And I haven't mentioned partitioning on purpose. Look, if you're coming from Postgres or Oracle or SQL Server and you've used partitioning your whole database life because you want to skip data, look, we don't do that in ClickHouse. We don't use partitioning to skip data. We use a good primary key to skip data in our queries. So yeah, you can partition by something, but we have one very simple recommendation. We recommend that you partition by month, and that's it. I'm going to go back a slide. I just want to make one comment here. What we really focus on with partitions is data management. That's really what it's all about. So you can partition by, but like I said, we have one very simple recommendation, and that's partition by month. And the only exclusion to that is if you just have so much data every day that you can partition by day. But that's really it. Partition by month, partition by day, depending on how much data you have. That allows you to move the data around. That allows you to drop well, here, I'll go to the next slide. You can drop a partition, move a partition. You can do a hot, warm, cold thing with these partitions, all nicely done. If I go back to this other slide here, it's saying, look, don't use a partition to try and skip granules or to try and skip rows. It can help with that, but the problem is you get too many parts. Don't use a customer ID number as a partition. Your only rows with the same customer ID can go in the same part. And so you're sort of setting a minimum number of parts, which could be too many. Don't partition by geography, like a country or a city or something, or an email address, or I don't know. All the things that you probably have done in the past with partitioning, we don't do that in ClickHouse. It's rarely a good idea. So keep that in mind. All right. And like I said, only parts with the same partition key can go in the same folder. So you can get too many parts. It's kind of like a bad design. It's an anti-pattern to partition by anything but month. So keep that in mind. All right, we got 2 labs here at the end of chapter 3. You're going to see what happens when you change the primary key or change not the primary key. When you change your data types, you're going to see what happens some big tables, and you're going to use low cardinality and not low cardinality and see the difference in the column sizes. It's pretty cool. And then you're going to define a merge tree table and put some cryptocurrency data in it. So off you go. Like I always say at the end of these modules, the community Slack channel has a ClickHouse Academy channel in it. We're there to help you anytime you want. And good luck. Off you go.